Okay, so now it's recording, yeah? It's recording. Okay. All right. So, all right. Let's look at this. Let's look. Okay. So, chapter 7 is about oscillation and waves, yeah? So, this chapter is a long chapter, yeah? Actually, it's the longest chapter compared to previous chapter. It's the longest chapter. Going to spend some time. So it's actually the combination of 3 chapters. Yeah? Before this, we have 3 chapters, and now all these 3 chapters combine into 1 chapter. Yeah. So first we start with simple harmonic motion, and then 7.4 is about mechanical waves, and then 7.6 above is about sound wave. So actually consists of 3 chapters here. All right. So now we focus on kinematics of simple harmonic motion 7.1 for today. Right. So okay. So start with this. Yeah. So periodic motion. Yeah. We have learned about linear motion, circular motion, and rotational motion. Right. Linear motion is things moving in straight line. Circular motion is, you know, we find the displacement, velocity, acceleration for all these 3 kind of motion, right? In circular motion, we also find the, you know, the the distance in the circle. We find the angular displacement, also velocity, acceleration. Rotational motion, also we find the angular displacement, acceleration. Okay, now we come to the another kind of motion, which is called oscillation. So today we will learn about oscillation. We already learned about linear motion, circular motion, rotational motion. Now we learn about oscillation. So oscillation is also called a periodic motion. Why we say it's a periodic motion? Because it always repeat itself. Repeat itself every period. Every regular time interval, every period, it repeat itself. It always repeat. Yeah, repeat. It's a repeating motion. Yeah, you see, it always repeat itself. So it's a back and forth motion about a fixed point called the equilibrium position. Equilibrium is the center line. Equilibrium. Yeah. Like this is the simple pendulum. Okay, oscillation. This is a spring mass system going up and down. So the equilibrium is at the center. This one pendulum also equilibrium at the center. This ball also, you see, oscillate. So oscillation of block with attached to a string, you know, movement of child on a swing. This is like the child on a swing. Yeah. Motion of pendulum. Piston in a car engine. You know, piston in a car engine always go up and down also. Vibration of atoms in a solid. Yeah, even the atoms also vibrating. We just cannot see it with our eyes, but atoms, they always vibrate. Yeah, so this vibration also a kind of oscillation also. So we study a special kind of periodic motion that occurs in mechanical system. This is what we call simple harmonic motion, SHM. Yeah, simple harmonic motion is simple harmonic motion is a periodic motion. Yeah, always go back and forth. Yeah, and it has an equilibrium position. Okay, so the next slide. So now we learn about kinematic. Remember what is kinematic again? Yeah, let me. Okay, kinematics. Okay, make sure I can write something here. Yeah, kinematics is you know, learn about displacement, velocity, acceleration. These are kinematics lah. Understand? Displacement, velocity, acceleration in the simple harmonic motion. All right. So yeah, we can go to here. So simple harmonic. Let me see. I'm recording, right? Yeah. Just want to double check. Okay. What is simple harmonic motion? Simple harmonic motion is a periodic motion without loss of energy. In which the acceleration of a body is directly proportional to the displacement from equilibrium position, but is directed towards the equilibrium position, but in opposite direction of the displacement. Maybe we need to break up this statement. We need to break up this statement. First, what is SHM? Is without loss of energy. That there's no loss of energy. And one more thing is acceleration is proportional to displacement, and also opposite direction to the displacement. Okay, so that means what is SHM? Simple harmonic motion. Okay, let me simplify it. It is a motion without loss of energy. Make sure you prepare your notes. You have a paper just beside you. Write down the notes. Okay, you have a paper beside you. Write down the notes. Not just listening lah. Yeah, your hand must be writing something. Must be write down the notes. Okay, without loss of energy. And one more thing is acceleration is proportional to the displacement. Displacement we put as symbol y lah. Yeah, later I explain why we use symbol y. Yeah, acceleration proportional to displacement. And then third is acceleration is opposite the displacement. So these three statements explain what is simple harmonic motion. Without loss of energy, that means no damping happen. No damping. Do you understand what is damping? Damping, that means an oscillation will become slower and slower until in the end it stops. That means, when damping happen, actually every kind of oscillation finally it will stop. Yeah, in our world, any kind of oscillation it will stop finally. Yeah, except vibration of atoms. Vibration of atoms, there's no loss of energy. But any kind of oscillation we see with our eyes always undergo damping. That means it will have loss of energy. So this one, simple motion, is without loss of energy because we are looking at ideal condition. Yeah. That means we are looking at we don't want to consider about damping, because if we consider about damping, the whole thing become more complicated. So we don't want to include, we don't want to consider about loss of energy. So we consider like, this oscillation will happen forever. Without loss of energy, that means oscillation will repeat forever. That means it will oscillate forever. Forever oscillation. That means that thing will oscillate forever. Yeah, I think I should write it like this. It will oscillate forever lah, because no loss of energy. Yeah, oscillate forever. Consider ideal condition. No loss of energy. It will oscillate forever. Yeah, the thing will oscillate forever. Yeah. And then the acceleration is proportional to displacement. That means if displacement increase, acceleration will increase. Okay, I will explain this later. And then acceleration must opposite direction to displacement. This is about direction. The acceleration is opposite the displacement. Okay. This is write down this one. This is the displacement. Okay. Acceleration is proportional to displacement. Acceleration is opposite to displacement. So what is this? So these three points, remember that. No loss of energy, acceleration proportional to displacement, and acceleration opposite to displacement. Okay. Now mathematically, this is the formula. This is what we call the SHM formula. SHM equation. So you can see acceleration is proportional. Acceleration is proportional to displacement. When displacement increase, acceleration also increase. And some more got negative sign. What does it mean by negative sign? Negative sign means acceleration is opposite the displacement. Opposite the displacement. Yeah. So the negative sign indicates the direction of acceleration is always opposite to the displacement. So that is the definition of simple harmonic motion. Yeah. And the omega is actually always constant. Okay, omega is related to the period. Because every kind of oscillation it will have period, right? Like you see this oscillation. How to calculate a period? A period is, that means it goes up, goes up, goes back down, and then go down and goes up back to the equilibrium position again. At the center is what we call equilibrium. Okay, so this block goes up, goes down, and goes back to the same position. This is what we call a period. The time span is one period, and then the oscillation repeat itself over and over again. Consider no loss of energy. This oscillation will happen forever. Okay, so omega here actually, we do you remember we learned about omega? Omega is 2 pi over period. So this omega is related to how fast is the oscillation. How fast is the oscillation? How much time for one complete oscillation? That means if the period is small, that means the omega is high. Omega high means fast oscillation. Fast oscillation. You know fast oscillation? And then short period. Short period. Okay. Understand, class? Do you get a meaning? Do you get what it means here? Okay. If you have short period, that means you have high omega. High omega means a fast oscillation. Okay. Later, or we can say, and one more thing. One more thing here. This omega is also 2 pi f. 2 pi f. Remember that? So short period, high frequency. Yeah, high frequency. High omega, high frequency, short period. That means this is a fast oscillation. If fast oscillation, you will have high omega, high frequency, low period. Low period means short period. That means it uses very little time to complete one oscillation. That means it's a very fast oscillation. Okay, so okay, I will explain this 3 point later. Yeah, just what is A? A is acceleration of the body. Omega is angular frequency. We call it angular frequency. Remember last time we used to call this angular velocity. But now we change. We use angular frequency. So okay, I want to tell something here. When in circular motion, which chapter is circular motion? Chapter 5, isn't it? And then we have rotational motion. This in chapter 6. We use omega. We call omega as angular velocity. Okay, angular velocity. And our unit is radian per second, right? Class, betul tak? But in simple harmonic motion, or we call it oscillation. Now we learn about oscillation. Ayonan. Which chapter? Chapter 7. Our omega has a new name, but it's still the same thing, It's still the same thing. It has a new name. We call it angular frequency. So this angular frequency is the same as angular velocity. But in this chapter, we normally call it as angular frequency instead of angular velocity. And the unit, you can either write it as radian per second, or sometimes we just put it as per second. Actually, this radian boleh ada atau tiada. Boleh ada atau tiada. Tak semestinya kena tulis. Understand? So you can, this radian is not a unit actually. This Ini radian boleh ada atau tiada. You can write it radian per second or per second. So later you will understand. Yeah? Right now you just copy the notes first. So it has a new name called angular frequency. Omega. But it's not frequency. It's angular frequency. It's not frequency. If frequency is just frequency lah. If frequency is just frequency. Frequency is per second also lah, or hertz. Okay. But omega is angular frequency. Omega is angular frequency. F is frequency. Okay. They are different. They are different. Omega is 2 pi f. Okay, good. Continue. Why just now I say simple harmonic motion? Omega, all right. Okay. So, why just now I say acceleration proportional to displacement and then acceleration opposite displacement? Let me see. Then this one. Okay. This one no. Maybe this one. This one. You see? Do you see? Do you see this? Oh. Do you see this? Animation here, class? Do you see animation here? Can so this animation is I created. Physics Adore is a brand. I made it using Adobe Animate lah. Yeah. Anyway, you can see the blue line. The blue line is actually the displacement. You see that? The blue line is the displacement. The red line is the acceleration. Do you see what happened here? Let me show it. See that? You see the blue line here? Blue line is the displacement. Blue line is the displacement. And then the red line is the acceleration. Do you see what's the relationship between the blue line and the red line? They are opposite direction. Right or not? The displacement and acceleration, they are always opposite direction. And one more thing, if the blue line is long, can I stop it? Oh, sorry. No, I cannot stop it. I need to create this as animation, make it I can stop it. So you see, this blue line and red line, they are always opposite. Opposite in direction. And when the blue line is long, red line also long. That means blue line and red line, they are proportional. Neglect the orange one is the velocity lah. Because velocity is highest at where? Velocity is highest at the equilibrium. But at the end, the orange, I'm talking about the orange line. If at the amplitude, the velocity is 0. See that? Velocity is 0. And what is the red bar, green bar here? Red bar is the kinetic energy. Kinetic energy is maximum at the equilibrium, right? But kinetic energy is 0 at the amplitude. Kinetic energy is 0 at the amplitude. And one more thing, the green one is, what do you guess? The green bar is referred to what? It refers to potential energy. That means the elastic potential energy of the spring. That's why I put the green bar near the spring. The spring has the green bar. The green bar shows the elastic potential energy stored in the spring. During maximum compression, you see that? Maximum compression, it has the maximum compression or maximum extension. It has the maximum potential energy. Can you see that, class? Maximum. Compression maximum. Extension maximum. Compression maximum. Extension maximum. Elastic potential energy. And then the energy interchange with the kinetic energy. This is what you call conservation of energy. At one time, at the amplitude is all elastic energy, right? Here amplitude. At the amplitude, you have maximum compression and maximum extension. That's where you have the maximum elastic energy at the amplitude. But once it goes back to equilibrium, all the elastic potential energy change to kinetic energy of the block. That's why at the equilibrium, it has the the red bar is maximum. It has the maximum kinetic energy at the equilibrium. Velocity maximum where? Velocity maximum, you see the orange line. The velocity is maximum at the equilibrium, but velocity is 0 at the amplitude. See that? You see that the arrow becomes 0 at the amplitude? Because velocity is 0 at the amplitude. But looking at the blue line now, blue line, the displacement is maximum where? Displacement is maximum at the amplitude lah. But displacement is 0 at the equilibrium. You see y equal to 0 at the equilibrium, but at the amplitude it has the maximum displacement. You see the blue line, if going to the right, is positive displacement. If the blue line at the left is negative displacement. Here also got positive, negative, plus got positive, negative. And then how about acceleration? Acceleration, when displacement is 0 at the equilibrium, displacement 0, so acceleration also 0. The acceleration is 0, but acceleration is maximum at the amplitude. Why acceleration is maximum at the amplitude? Why? Because acceleration is related to the force, the force in the spring. Okay, I will explain later. Okay, so I explained a lot of theory already, using just one animation here, right? A lot of theory inside, but you have to look it one by one lah. I will explain one by one, don't worry. So there's some rough explanation there. Okay, let's look at this one. This class, so do you understand what I'm I talked a little bit about the theory just now. Do you understand what I'm saying? Okay, you can get it, right? You must you must take time to understand. Never mind, this video I will upload to YouTube. Later you listen again what I'm saying about the animation just now, right? You just look back to the video, right? Okay, looking at this example, you see this simple pendulum and horizontal spring. You have horizontal spring, you have vertical spring, why just now where's the animation? Go back to the animation. Where is my animation right just now? That which one? This one, right? Okay, then I also relate to this one. Okay, this one and this one, right? Okay, class. Just now, why do I say acceleration is maximum at the... that's why I say just now acceleration is proportional to displacement. Acceleration opposite to displacement always. When displacement at the amplitude, amplitude displacement is maximum, acceleration also maximum. Why? That means like this one is at the amplitude, right? This mass is at the amplitude, so I can say, see that the below here, it has maximum displacement. So I can say here, it has the how should I write? It has the positive y maximum here, over here, right? Because at the center line is what we call, center is 0 displacement. Center is 0 displacement. If the object is over here, it has the maximum displacement, and over here also it has the maximum, but opposite direction. The acceleration is maximum. Here the acceleration also maximum. Why we say acceleration is maximum also, but opposite direction? Why acceleration is... So you see, displacement is to the right. Why acceleration to the left? Why? Because of formula. Look at here. F equal to ma. F equal to MA. And what is the F here? F is the rest, we call it Fs. Fs, what is Fs? Restoring force. Is what we call restoring force. Do you understand what is meant by restoring? Restoring, that means I want to bring back to equilibrium. A force to bring back to equilibrium. Of course, the more the object go to the right, the more the object want to go back to equilibrium. Because of the gravity. Gravity want to bring this mass back to equilibrium. That's what called as restoring force. This restoring force is actually a component of the gravity. But if spring, the restoring force is the force in the spring. So this restoring force can be forced by the gravity. Gravity want to bring the object back to equilibrium. Or it can be force of the spring. What is the function of this restoring force? Bring object, dia nak balik ke equilibrium. Bring object back to where? To equilibrium position. Bring the object back to equilibrium. That's called restoring back to the original condition. Bring the object back to equilibrium. It can be from gravity. For pendulum is gravity. For spring mass system is spring lah. Got force in the spring. So the only force acting on the mass here is the restoring force. For pendulum is gravity. So you see, F equal to ma. So restoring force equal to ma. So the direction of the restoring force the same as direction of acceleration. That means restoring force nak pergi mana, acceleration pun pergi mana. Faham tak? Restoring force pergi mana, acceleration pun pergi mana. So ini restoring force want to go back to equilibrium. So of course, why this thing always come up? So the restoring force want to go back to equilibrium. So that's why acceleration also go to the same direction. Acceleration, same direction as the force. Acceleration, same direction as the force. So restoring force, I can say the restoring force also maximum at the you know, how should I write here? The restoring force also maximum at the here maximum displacement is called the amplitude. At the amplitude, displacement maximum, acceleration also maximum, restoring force also maximum. But this acceleration and restoring force, they are opposite direction to the displacement. Understand? They are opposite direction. They are maximum also, but opposite direction to displacement. Look back my you see? Go back to this. See? The blue line and the red line. You see? At the amplitude, both line is the maximum. See that? Both line is the longest for displacement and acceleration. The longest at the amplitude, but opposite direction. You see? When displacement positive, see? When displacement positive, acceleration negative. When displacement negative, see? Displacement negative, acceleration positive. They are always opposite direction. Because why? Why acceleration always, you see, acceleration always point towards the equilibrium. Why the acceleration always points towards equilibrium? Because restoring force want to go back to equilibrium. Restoring force always towards equilibrium. So acceleration always towards equilibrium also lah. Because acceleration follow the force, follow the restoring force. Let me see your hand. Do you understand, class? Do you understand? Give me a thumbs up if you understand. Okay lah, ya. Tidak sia-sia saya explain di sini. Okay, at least you understand, Okay, thank you. Alright, so alright. Tidak sia-sia saya buat animasi ini. You faham kan? Tidak sia-sia lah. Okay. So maksudnya kalau objek kalau objek sudah pergi ke sini, mana displacement dia? Displacement dia negatif kan? See here? displacement negatif, maximum. So dia punya force ke mana pula? Dia punya force adalah ke sini. Force dia pula jadi positif. Dia punya apa? Dia punya acceleration pula jadi positif. Because kalau y negatif, a positif. They are opposite direction. Sebab a ialah negatif y, negatif omega square y, negatif opposite direction. Force pun opposite juga, ya. Tadi ini a negatif lah kelas sebelah sini. Kalau y positif, a negatif, f pun negatif. F pun negatif. Ya, begitu. Kalau tengok ini spring mass system sama juga, ya. Kalau objek di sini, kalau y dia positif, a dia akan jadi negatif, f pun negatif. Kalau objek pula di sebelah mana? Kalau objek di sebelah sini pula, kelas. So itu spring kena compress kan? Spring kena compress mestilah dia nak, spring kena compress mestilah spring nak push itu objek balik kepada equilibrium kan? Takkan dia nak tarik lagi. Takkan dia punya force nak tarik lagi ke dalam. Mestilah dia nak push. That's why restoring force-nya adalah ke kanan. Kalau dia punya, if the y is negative, so dia punya force of the spring must be, force of the spring must be positive, opposite direction. So acceleration dia pun apa? Banyak warna, saya pun tak tahu warna apa sudah, ya. Saya pun tak tahu apa warna sudah. Positif, begitu kan? So F ke mana, A mesti ke mana. Tahu tak? Tapi A dan F mesti lawan arah dengan displacement, mesti lawan arah. Sebab kalau you kena compress, mesti you nak push dia balik kepada equilibrium. Dan center line ini panggil apa? Equilibrium. Kalau spring kena extend macam ini, kalau kena extend macam ini, mestilah dia nak tarik balik. So kalau nak tarik balik, force menjadi negatif walaupun displacement positif. Dia lawan arah. Macam itulah. Sama lah kalau vertical circular. Why suddenly become Malay? Okay. Alright. So that's explanation lah. So if vertical, same thing lah. You want to pull back. If the object goes up, the spring want to push back down like that. Yeah. So same thing. Understand? Let me also draw it. Let me draw it here. So the force, force go down. So acceleration go down. But displacement is go up. See that? So opposite direction. Okay. Good. So here is positive. Here negative. Yeah. But for so force and acceleration here become negative, opposite to the displacement. This one y negative, this force become positive, opposite direction. Always opposite lah, okay? Because they want to go back to equilibrium. Okay, good. See, I already explained all this, right? In the process, Okay, so terms used to describe simple harmonic motion. So you already learned about, equilibrium position. It's the point where the acceleration and the force exerted on the body undergoing oscillation is zero. You understand what it means here? Acceleration and the force is zero. That means kalau objek di equilibrium sudah, kalau objek di sini, that means spring itu tak ada force lah. If the object is at the equilibrium, if object at the equilibrium, that means ataupun begini, if y equal to 0, acceleration also 0, force, the restoring force also 0. Use this equation, you see, a equal to negative omega square y. So that means a equal to negative omega square y, and F sama dengan MA kan? F sama dengan MA kan? Kalau Y0, Acceleration also zero. Betul tak? Kalau acceleration sudah zero, force pun zero lah. Okay? When displacement zero, negative omega square multiplied zero also zero. So force also zero. So at the equilibrium, kalau object di equilibrium, that means itu spring pun tak kena compress. Itu spring pun tak kena extend. So of course force in the spring is zero. So acceleration also zero. Right? Understand? So acceleration depend on force. Kalau ada force, adalah acceleration. Kalau tiada force, dia adalah acceleration. Faham tak? Kalau ada force, ada acceleration. Kalau tiada force, tiada acceleration. Begitu je. Okay? Kalau acceleration kosong, force pun kosong lah. Okay. Baik, so displacement is how far from you, how far from the equilibrium, how far from the equilibrium. That is the displacement lah. How far from the equilibrium. If you are at the equilibrium, means displacement zero. Okay. So amplitude means the maximum displacement. Amplitude means what? Maximum y, maximum displacement. Maximum displacement. The unit is meter. Period is the time for one circle. Time for one circle, and is second. Frequency is number of oscillation in 1 second. That means, yalah, faham kan? Takkan tak faham lagi. Frequency. Frequency that means number of oscillation dalam satu saat. Kan dulu kita belajar frekuensi masa circular motion, frequency for rotational motion. That means how many revolution in 1 second. Ini ialah number of oscillation in 1 second. Almost the same thing. Number of oscillation in 1 second. Okay. Formula masih sama. Kita tengok pakai balik F equal to 1 over period. Macam your rotational motion kan. Unit is still hertz per second. So use back the same thing. Omega now is called frequency instead of angular velocity. It's called angular frequency. 2 pi f or 2 pi over period. You see, use back the same formula. Unit radian per second. Sometimes we write as per second only. Also got, yeah. You will see in the question later. Sometimes we write only with per second. Restoring force. What is restoring force? A force tends to bring the system back toward equilibrium. See that? Back toward equilibrium. Yeah, can be forced by the spring or forced by the gravity. It always directed towards the equilibrium. See? Always directed towards where? Towards equilibrium, because we want to bring back to equilibrium. And it's directly proportional to the displacement at the instant. Like F equal to kx, F equal to negative kx. Force in the spring, see that? X is the extension or compression. So if the higher the displacement, higher the force in the spring. F equal to negative kx. Why got negative? Why got negative? Negative because opposite direction. Negative means opposite. Apa opposite apa? Force opposite the displacement. Force opposite the displacement. Okay? Okay, good. This one got animation. Let's see. Where's the animation? I think this one. Yeah. Where is it? Where's the slide for that one? Oh, slide for yeah, here. See that, class? So we are in this part 7.1. So here got animation. See, somebody coming in. Yeah, somebody coming in. Just coming. Kelaparan masuk. Okay, siapa lagi? Okay, so let's look at this one. So you see, kinematic of symbolic motion. Yeah. So kinematic can be found in the kinematic of equation of the symbolic motion can be found from a relationship between symbolic motion with uniform circular motion and sinusoidal curve. Actually, this one got is but it become an image only. Never mind. Object does a simple motion behave very similar to the object that move in a circle. The radius of the circular motion is symbolic of the amplitude. Class, you just see this. Maybe this diagram is better. Do you see something here? This is a very good example. Do you see this thing? This is you see the red ball here. It goes up, goes down. This is oscillation, isn't it? I cannot write here. Can I write here? Yes, I can write here. So this here is a oscillation. Yeah. So you can see this part. This is an oscillation, right? Oscillation, right? Oscillation of the red ball, and then you can see the this one is a circular motion. Okay. Can you see? Why this? See that? Come on. See that this one? This is the oscillation, and you can see this one is a circular motion, right? Can you see how you relate to each other? And you can see the circular motion. You can see the circular motion. Actually, they form a sinusoidal curve. You know sinusoidal curve, a sine curve? And then you can see this is all about our chapter here. This is all about our chapter here. I want to stop the animation, but I can't. Do you see this oscillation here is actually the y component of the circular motion. It's the y component. Okay, let me show you the keep it. Yeah. So where is the like this? Yeah, this one. You see this one? Just now the red ball. The red ball is just like our pendulum, going up and down, going up and down, going up and down. Yeah. So class, give me some signal if you understand. Okay, you see this simple harmonic motion is the going up and down, just like the red ball here, just like the red ball, right? And then you can see also the circular motion, it going circle and circle and circle. Yeah, it going circle and circle. It's the circular motion lah. Correct or not? And then you also can see this circular motion and the oscillation. They are related to the graph also. Let's look again. You see the circular motion and the oscillation, they are related to the graph. See that? See that? Related to the graph. When graph go to maximum, this ball also at the maximum. Where the amplitude means they are at over here this position. At the bottom, at the bottom means all also at the bottom. When at the top, all at the top. When at equilibrium, all at equilibrium. See that, class? And okay, yeah. This is what it means here. You see, just now you can see the red ball. The red ball refer to this mass lah, the spring mass, and then you can see the circular motion refer to this circular motion, and you can see the sinusoidal curve. This one sinusoidal curve. So it's like this tree diagram. Yeah, this tree diagram. Yeah, that means this whole thing is like this tree diagram. So they are at the same position all the time. Kalau di atas, tiga objek pun di atas. Kalau di maximum, semua di maximum. Kalau di equilibrium, semua di equilibrium. Betul tak? So I want you to see one thing here. How to get this equation? This is as I said just now. What are we learning right now? We are learning about kinematics. We are learning about kinematics of simple harmonic motion. So, kita sudah belajar linear motion. Object going, object going to the left, to the right, up and down. Okay, we study about the displacement, velocity, acceleration, semualah kan. Then kita belajar circular motion. Kita belajar dia punya displacement, dia punya velocity, acceleration juga. Sekarang kita belajar this oscillation, going left or right, going left or right. So kita pun nak tahu dia punya apa? Displacement, dia punya velocity, dia punya acceleration juga. Faham tak? So kita sedang belajar dia punya displacement. Cuma kita punya simbol sekarang bukan guna S lah, kita guna Y ya. Kamu akan faham why we use Y instead of S. Why we use Y instead of S. Yeah, later we understand. So now we are learning about this oscillation. We can regard this like oscillation lah. Yeah, simple motion is like oscillation. Okay, so we are learning the displacement, velocity, acceleration, also the kinematics of this oscillation. So how to calculate? How do you calculate the displacement, velocity, acceleration? How do you calculate the value? Like just now you see my animation here, right? You see my animation here. Okay, good, very nice. You did see the displacement, velocity, acceleration, but do you know how to calculate their value? Do you know how to calculate displacement at any time, or velocity at any time, or acceleration at any time? Do you have the formula to calculate? I want the value. Can you give me the value of these three quantity? You don't have. So you have to learn. So okay. So we have to learn how to calculate, these three value: displacement, velocity, acceleration. So that is the purpose of our study today. Okay. So what's the formula? This is the formula. This is the formula: y equal to a sine omega t. That's the formula to calculate, to give me the value of displacement at any time. Got time here, you see that? At any time, because why? At different time, the object is at different place. Yeah, sometimes the object at the equilibrium, sometimes the object at the amplitude, sometimes in the middle between the amplitude and displacement. So I need an equation to calculate. So that's the equation. And how do you get this equation? That's why I'm talking about this, this thing. That's why I'm relating this, this oscillation, these three things: the oscillation with the circular motion and with the sinusoidal curve. I need to relate these three things, then only can get the formula. You understand? You understand the purpose? Good. So let us look one by one. Yeah. But I won't take long. It's already almost 9. But I want to get an idea. Get an idea only. Get an idea. So you see, how do you get this equation to find the displacement? You have equation for displacement with time. You have equation of velocity with time. This is the equation for velocity. And also you have also the equation of velocity versus displacement, and you also have equation for acceleration, acceleration with time. And just now got these three quantity here: y, v, and a. Yeah? Displacement, velocity, acceleration. And what's the equation? This is the equation: y equal to a sine omega t, v equal to a omega a cos omega t, and acceleration equal to negative omega square a sine omega t. That's the formula. And how do you get this formula? That is what we're going to discuss later on. Yeah, but maybe today we just stop at this one equation only. Yeah, one equation only. Look at here. Kaki saya kejang pula. Yeah? I sit in the wrong position. Hold on a second. Kaki kejang betul lah. Semut betul. Alright. Okay, so you see just now I relate these three things, oscillation, the circular motion, and the sinusoidal curve. You can see here, this here, this line, this is the amplitude, correct or not? It's not. I'm saying this is the radius, lah. I can say this is the radius, right? Radius of the circle, right? This radius is actually amplitude. You regard it as an amplitude. Yeah, amplitude. You know what is amplitude? This radius is amplitude because kalau objek sudah pergi ke sini, betul tak? The radius is means itu blok pun sudah di sini, betul tak? Blok pun sudah di sini. So itulah amplitude, betul tak? So this is the amplitude. Understand? Kalau blok sudah pergi sini, give me a thumbs up if you understand. Kalau blok sudah di sini, means dia di amplitude kan, betul tak? Dia di amplitude. So panjang amplitude kan radius dia, betul tak? Panjang amplitude ialah radius dia. So I can say the radius is the amplitude. Radius is always constant. Radius is always constant. So that means kalau objek di sini pun, ini panjangnya masih amplitude juga, betul tak? Kalau objek di sini, if the object is over here, this is still amplitude, correct or not? Because the radius is constant. Why I'm saying that if the object is over here, this radius is the amplitude lah. It's like this object is at the highest position. Look back the animation here. See that? See that? Stop. See that? When the circular motion is at the highest position, kan itu radius ialah amplitude, kan? Start. Terlalu cepat pula. Alamak. Jalan. One more time. Okay lah, terlambat sikit. So itulah radius is the amplitude, right? Okay, enough, yeah. Okay, wrap off all these, Okay, class. How do you get this y? This is the most important concept here. How do you get this? Apa ini y sebenarnya? Apa ini y? Y is the displacement we want to find. This is the thing we want to find. This is the displacement we want to find. The displacement of the oscillation. Do you know how to find this length? Very easy. Kan saya sudah cakap, dia punya radius tadi ialah amplitude. Dan kita tahu dia punya, ini theta. What is theta? Theta is the angular displacement. Right or not? Theta is the angular displacement. The angular displacement. How to write? Angular displacement. Okay? So, using what? Trigonometry. Sin theta ialah apa? Sin theta ialah apa, kelas? Opposite over hypotenuse kan? So, dia adalah y bahagi A. Y bahagi A. So, nak cari y ialah A sin theta. A sin theta. So, ini y sebenarnya sama dengan y component untuk amplitude ini, atau y component of the radius. Okay, let me draw it here. Let me draw it here. So this this circle dia ada radius kan, radius. So dia ada dua komponen sebenarnya. Dia ada dua komponen. So kita nak cari dia punya komponen apa? Kita nak cari dia punya ry, dia punya y component. Dia punya ry ialah yang displacement yang kita nak cari. Dia punya y component sebenarnya. Dia punya ry ialah r sin theta. Tapi kita guna apa? A lah instead of apa? Kita guna amplitude, faham tak? Kita guna simbol A sebab kita sudah tahu at radius itu ialah amplitude. So ini AY, AX. So dia punya AY ialah A sin theta, faham tak? A sin theta. Kita bukan nak cari dia punya AX cos theta, bukan. Ya, bukan. So kita nak dia punya y component. So we just want the y component of we just want the y component. The y component of the amplitude is the displacement that we want to find. Yeah, so we got this formula, y equal to a sin theta, and then after that class, we also learn theta equal to omega t. Remember that? Because we learn what? S equal to ut plus half at square, isn't it? But you see this motion is so we also learn about theta equal to omega t plus half alpha t square. Half alpha t square. But this alpha is 0. This alpha 0. Alpha is 0. Do you know why you use 0 alpha? Because uniform circular motion. We are talking about uniform circular motion because the period is constant. Looking at this one, you see this oscillation? Kan uniform circular motion, dia tak ada acceleration, dia constant speed saja, betul tak? Dia constant speed saja. So alpha dia adalah 0. Understand? Alpha dia 0, uniform circular motion, constant speed. So alpha nya kosong. So maksudnya formula ni theta ialah omega t je lah, sebab half at square itu sudah kosong. So theta itu, so ini formula jadi apa? Jadi apa kelas? Tuan-tuan, bagi tahu saya. So dia jadi A sin omega t. Itulah formula dia. Macam mana you derive ini? We have learned that circular motion theta equal to omega t, alpha uniform circular motion, ya. Itulah dia. Okay? So actually kamu matematik pun belajar, kan? Matematik belajar ini A sin omega t. This is a sine curve. If you look at mathematics, this is a sine curve. And A is the amplitude. A is the amplitude here. Sini negative amplitude, right? So itulah dia. See? A is the amplitude. Oh, ada bunga api ya. Malam Merdeka ni. Okay, di luar ni. So, okay lah. I think sampai sini kelas, you faham kelas? Boleh faham? So, dia simple je. Macam mana dapat y equal to a sin omega t? Pendek kata, dia adalah y component. Y component of the amplitude. Itu sahaja. Y component of the amplitude. Then theta itu kasih ubah kepada omega t je. Sebab line masa, line displacement. Itu sajalah kelas. Nanti velocity nanti ini minggu depan Sabtu lah kan. Saya kena tunggu hari Sabtu minggu depan. Sabtu malam kita bincang lagi tentang velocity acceleration. Boleh? So minggu depan lah. Ya. Untuk kelas minggu depan ni nanti saya nanti kamu tak payah datang kelas, tapi saya akan bagi kerja rumah. Ya, saya akan bagi kerja rumah. Nanti you buat secara offline je ya. You buat latihan je ya dekat bilik kamu. Ya, kamu buat latihan saja. Saya bagi latihan lah. So you buat saja, bincang dengan kawan. At least you ada kerja buat lah. Okay. Dan saya balik dari KL nanti. Saya buat kelas malam lagi. Ya. Okay, thank you kelas. Selamat malam. Bye. Okay.